Hey guys, it's me Mole. I just wanted to make this quick video, like a 10-minute video, because I know my original video was like 45 minutes long, and I don't want you guys to do that much watching before the actual test, so I'm making a really quick video where I just explain everything really quickly. Please, because I'm not going to explain the enzymes, please watch the previous video just to know the enzymes and their functions. That's going to be in the first 5 minutes of the video, so you can quickly just go through that before actually watching this video. And I'm also going to be working on yesterday's topic with the Amoeba Sisters video. I'm going to try to explain that as well. Let's first start off with our actual lesson, which is going to be the DNA. We're going to have this as our DNA. I'm going to try to make a really good diagram this time, so mind the pausing. Okay, so how it works is extremely simple. So this is Topo. Topo loosens the DNA, and oh yeah, by the way, this is the DNA. I hope you understood that. But I just need to see a quick diagram and see where the primes go. Yo. Okay, so this is gonna be 5 to 3, and then 3 to 5. Okay, this is helicase. All that helicase does is that it constantly unravels the protein. Okay, so that's what helicase does. It unravels the protein. This is the original DNA. I'm going to put that in blue. So this is the oDNA. This is the oDNA. oDNA stands for original DNA. And I want to make these blues a darker blue so that you know that these are the new DNA, right? Alright. So, to put simply, DNA polymerase, which is the DNA to create the complement strand, and the complement strand is the strand that connects with the original DNA. Remember, it's not the identical of the DNA, it's the complement of it. So the base pairs, so like A to T, it's not going to be A, C, C, C. It would be like T, G, 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 because that's the one that complements the original DNA strand, right? So DNA polymerase makes a complement of it. Now, before DNA polymerase actually works, they need to know where to start in the complement making, right? So that's where primase comes in. What primase does is it signals DNA polymerase to say, hey man, start here, okay? Start here, and then start making the complement of the DNA. And DNA polymerase is like, yeah, cool, I'm gonna start. Now, the thing about DNA polymerase is that it goes in a 5 to 3 direction, right? So this goes from 5 to 3. Now, to stupidify this as easily as I possibly can, and I want you to highlight this and understand, DNA polymerase wants to go to 5. So anywhere you see in the diagram, that's where DNA wants to go to. DNA polymerase goes to. So you're seeing the 5 here. So oh my gosh, what did I just do? DNA polymerase wants to go to this 5 right here. And this right here, DNA polymerase wants to go to this 5 right here, right? So all it does is just wants to go to the 5. Don't try to make this complex on yourself and know 3 to 5, 5 to 3, all that stuff. That's going to be too much work for you guys, okay? To put it in the easiest way possible, okay? It just wants to go to 5. 5 is where it's left to go, and it wants to go to 5, right? Now, see where the direction of the helicase. The helicase is going this way, right? And it's unraveling the DNA in this direction, right? In this direction. Well, this is fine for one of the DNA complements. See, this DNA complement is perfectly fine because it can just move forward the DNA polymerase and constantly make the DNA and finishing the complement of this strand and, making the replication of the DNA. But look at this one. Remember, it wants to go to the 5, right? So this one's going to continue going this way. But then as the helicase is moving in this direction, what happens to this area? It's not getting any of it being filled. It's not getting the complement of the DNA, right? So what happens? Now, before we start explaining what happens here, I just want to get some key vocabulary over here, right? So this is called the DNA polymerase. This is called primase. And these and one, wait, why is my mom? Okay, and this entire thing, right, where they're doing, and see how this one's just doing it in one fell swoop, it's just moving forward, right? You can see how this thing is just constantly moving forward. That's what we're going to call the leading strand. Now, this, since it's going this direction, and this place has nowhere to go, what do you think is going to happen next? Primase will have to go and say, hey man, this area is not being filled. I'm going to go back here, right? And primase will set the signal, and that DNA polymerase, right? That DNA polymerase will go back there, okay, and fill in this portion that it didn't fill, right? And they'll say, oh man, this place ain't getting filled, right? So it's going to go back here and say, hey man, hey DNA polymerase, you're not filling this area in. Go back here and finish this area. And what this does is, since it's constantly trying to move it back, it creates these fragments almost. They're not properly connected. Remember, DNA, the original strand of the DNA right here, it needs a full complement. Because when they're going to go back to double helix, into their double helix form, it should be looking like something like this. Not something that it's in fragments where it looks, one of them is perfectly fine because that's the original strand, and another one is in fragments. That just won't work, and it's going to cause a lot of issues for the cell. So what happens is it creates these fragments, and these fragments are called Okazaki fragments. Okay? And these are here to say that, oh shucks man, these are the fragments. Now, this red guy here, we're going to call him ligase. He glues these oh my god, what did I just do? He glues these fragments together. So this red mark is symboling as gluing. Ligase glue these strands together, and it creates one nice big strand, right? And that big strand, one nice big strand, is exactly like this DNA strand, and it creates a DNA that looks like this. Okay, so that's basically the general idea of the DNA replication. There's a more complex and more detailed envisioning in my 45-minute video, but for the quiz, for those who don't have any time, this is just the best I can do to get all the concepts together without causing too much of a struggle. These are really the main things that are going to happen. And oh, I forgot one last thing. My bad. The fragment strands are called the lagging strand. And also memorize the DNA. The DNA one is not going to be that bad. This is everything. Yeah. See ya. I'm going to make another video for the lesson that we did on Amoeba Sisters.